How does thermal camouflage work with thermal imaging? Imagine trying to hide your heat signature from a device designed to see heat like a hawk. That's what thermal camouflage aims to do. It's all about fooling thermal imaging cameras that detect infrared radiation. These cameras don't see visible light, they sense the heat objects emit. So, to stay hidden, you need to control that heat emission. Thermal camouflage works by manipulating the infrared radiation coming from an object. The goal is to make your heat signature blend with the background. This can be done by blocking, absorbing, reflecting, or dispersing infrared radiation. Think of it like wearing a suit that tricks the camera into seeing a different heat pattern. Materials used in thermal camouflage are designed to emit infrared light in specific wavelengths. Since thermal imaging devices usually operate in mid-wave infrared bands around 3 to 5 micrometers, or long-wave infrared bands around 8 to 14 micrometers, the materials target these ranges. They can have low emissivity, meaning they emit less infrared radiation, making you less visible to thermal cameras. Another key aspect is thermal insulation. These materials reduce heat transfer from your body or equipment to the environment. Some advanced systems combine insulation with wavelength-specific emitters. This way, heat can escape in ways that don't get picked up by the camera. It's like having a heat shield that manages what the camera can see. Some newer materials can change their properties dynamically. For example, thin films with graphene layers can switch their thermal emissivity on command. This allows the camouflage to adapt to changing surroundings, making it harder for thermal imagers to detect you. These materials respond to environmental conditions or electrical signals, adjusting how they emit or reflected heat. Multi-layer films are also used in thermal camouflage. These are made of different materials like silicon dioxide, germanium, zinc sulfide, platinum, and gold. They are designed using computer algorithms to optimize infrared camouflage and heat management at the same time. These layers help reduce infrared emission in key bands while preventing overheating. In tactical gear and vehicle applications, thermal camouflage can be applied through special fabrics, sprays, or coatings. These materials combine insulation and selective emission properties to hide heat signatures. For vehicles, coatings can reduce engine heat or adapt to environmental temperatures, making them less visible to thermal imagers. However, there are challenges. Camouflage must balance reducing infrared emission with the need to dissipate heat safely. If it blocks too much heat, equipment or personnel might overheat. Thermal imagers are very sensitive to tiny temperature differences, so the materials need to be highly effective and tailored to specific environments. In summary, thermal camouflage controls the infrared radiation an object emits. It uses special materials and coatings to blend heat signatures with the surroundings. This helps keep personnel and equipment hidden during night operations or in low-visibility conditions. By managing heat emission carefully, it becomes much harder for thermal imaging devices to detect targets.